I've always associated MIT with something new and exciting that was kind of grasping towards the very best that we can do as humans. Using technology and science and putting knowledge kind of high up as one of the great things that we can do as a species to help others.
What I talk to with a lot of my friends about is that no matter what industry they're going into, no matter what they're studying, they're going to have to consider climate change in the much nearer future than a lot of people think.
Climate change is one of the fundamental challenges of the 21st century, one of the most pressing challenges we face.
And a problem that we don't have all of the science solved yet.
But that's what we're working towards, and that's why we created the 112 major that combines the expertise of Course 1, which is Civil and Environmental Engineering, and Course 12, which is Earth, Atmospheric, and Planetary Sciences.
It's meant to provide not just the solid foundation upon which someone can act, but the toolkit to allow them to act.
I thought, if I can really do anything, what is the anything that I want to do? And that's a little bit of how I stumbled into 112.
I was really attracted by how flexible it was. And I realized that if I switched into this new major, I could really see what I was interested in and sort of tailor my studies, tailor my research in that direction.
EAPS provides that fundamental foundation in climate and Earth system science, which is critical to understand climate change, why it's happening, but also to be able to model it.
Why is the Earth the temperature it is? How has that varied across Earth history? How might that project forward into the future?
Renewable energy largely depends on our ability to predict weather and climate variations, and so if you're interested in mitigating climate change, you also have to understand what is going to happen with climate change.
We teach atmospheric chemistry, fluid mechanics, field courses where students put what they learn in a classroom into practice, actually into the environment. But also, a number of our faculty are foremost experts in translating that science into action.
And then what civil and environmental engineering brings to the table in this major is how to think about engineering solutions to climate change. That's both in mitigation, so preventing further climate change, and also in adaptation.
Having the chance/requirement to take a class focused on energy has been actually super cool and kind of opened my eyes to the real limitations and challenges on making a more sustainable grid.
I mean, we're doing so much technical work, so much real science, so much real math, and that is the cool thing about the major, is that because it's giving you both that science background, climate science, but also engineering, you really have a fountain of opportunities.
I'm also really enjoying taking modeling for sustainability because it uses these more technical aspects of math, computer science, physics. And then there's the broader major requirements, which are a lot more flexible and can be on whatever you want.
There's such a need for this in the workforce, such a demand for it. And so through this degree, we're opening up a lot of doors for these students to actually go and find those exciting opportunities.
It's such a multifaceted issue that it's going to require people doing research in a lot of different fields and people coming up with a lot of different solutions.
I think 112 really is the major if you're interested in tackling directly some of the world's greatest challenges and having a career that is interesting and also really matters.